Welcome back to the Network Plus training series. In this lesson, we are covering Objective 2.4, Explain Important Factors of Physical Installations. Physical infrastructure is the foundation of every network. No matter how well your logical configuration is designed, if the physical installation is poor, the network will have problems. This objective covers the critical considerations for planning and implementing the physical components of a network. Let's start with structured cabling. Structured cabling is a standardized approach to cabling infrastructure that provides a comprehensive telecommunications cabling system. It follows standards like TF568 and ensures that the cabling plant is organized, documented, and maintainable. The main distribution frame, or MDF, is the primary wiring hub for a building or campus. It is where external connections from the service provider enter the building and where the core network equipment is housed. The MDF typically contains patch panels, switches, routers, and other core networking equipment. The Intermediate Distribution Frame, or IDF, is a secondary wiring hub that extends connectivity from the MDF to different areas of the building, such as individual floors or wings. IDFs contain patch panels and access layer switches that connect to end-user devices. The connection between the MDF and IDFs is called the backbone or vertical cabling. A demarcation point, or demarc, is the point where the service provider's responsibility ends and the customer's responsibility begins. This is where the external telecommunications line enters the building and connects to the customer's network equipment. Understanding the demarcation point is important for troubleshooting because it defines who is responsible for fixing problems on each side. Patch panels are devices that provide organized cable termination points. Cables from wall jacks throughout the building terminate at the patch panel. Short patch cables then connect the patch panel ports to switch ports. This modular approach makes it easy to make changes, troubleshoot, and maintain the cabling infrastructure without directly manipulating the permanent cabling. Cable management is essential for maintaining an organized and functional network environment. Proper cable management includes using cable trays, cable ladders, and cable raceways to route cables. Labeling all cables and ports for easy identification. Using appropriate cable lengths to avoid excess cable coiled up in the rack. Separating power cables from data cables to minimize electromagnetic interference. Using Velcro ties instead of zip ties, as zip ties can damage cables when over-tightened. Equipment racks and cabinets house network equipment in a standardized way. The standard rack is 19 inches wide, and equipment height is measured in rack units, or U, where 1 U equals 1.75 inches. A standard full-height rack is 42 U. When planning rack installations, consider proper spacing between equipment for airflow, weight distribution with heavier equipment placed lower in the rack, cable management within and between racks, and physical security with locking cabinet doors. Environmental considerations play a significant role in network reliability. Temperature is a major concern. Network equipment generates significant heat, and operating temperatures must be maintained within manufacturer specifications, typically between 64 and 75 degrees Fahrenheit or 18 to 24 degrees Celsius. Data centers and server rooms require dedicated cooling systems. Hot aisle and cold aisle configurations are used in data centers to optimize cooling efficiency. Cold air is directed toward the front of equipment, and hot exhaust air is contained and removed. Humidity must also be controlled. Low humidity increases the risk of electrostatic discharge, which can damage equipment. High humidity can cause condensation, leading to corrosion and short circuits. The recommended humidity range is 40 to 60%. Power considerations are critical. Uninterruptible power supplies, or UPSs, provide temporary battery power during outages, giving enough time to gracefully shut down equipment or for generators to start. Power distribution units, or PDUs, distribute power to equipment within a rack. Redundant power supplies ensure that if one power supply fails, the other continues to provide power. Properly sized electrical circuits and dedicated circuits for network equipment prevent overloading. Generators provide extended backup power during prolonged outages. Fire suppression in areas containing network equipment must use methods that do not damage electronics. Clean agent fire suppression systems, such as those using FM200 or Novec 1230, suppress fires without leaving residue. Water-based systems can be used in some situations but may damage equipment. Physical security measures protect network infrastructure from unauthorized access. Server rooms and wiring closets should have locked doors with access control systems. Security cameras should monitor critical areas. Visitor logs and escort policies should be enforced. Equipment should be secured within locked racks or cabinets. When planning cable runs, you must consider the maximum cable distances for the media type being used. For twisted pair Ethernet cables, the maximum distance is 100 meters, which includes 90 meters of permanent cable and 10 meters for patch cables at each end. Exceeding this distance causes signal attenuation and data errors. For longer distances, fiber optic cable or network extenders must be used. Proper labeling and documentation are essential for maintaining and troubleshooting the network. Every cable, port, device, and rack should be labeled. Network diagrams should be kept up to date, including both physical and logical diagrams. Change management procedures should document all modifications to the infrastructure. Site surveys are important when planning wireless deployments. A wireless site survey maps signal coverage throughout the intended area, identifies sources of interference, determines optimal access point placement, and validates the design after deployment. Heat maps generated during site surveys show signal strength throughout the area, helping identify dead zones and areas of excessive overlap. Let's review. Physical installations require attention to structured cabling with MDF and IDF design, environmental controls including temperature, humidity, and fire suppression, power management with UPS and redundant power, physical security, proper cable management and labeling, and site surveys for wireless deployments. Thank you for watching this lesson on Objective 2.4. This completes Domain 2. In the next video, we begin Domain 3 with Objective 3.1 on organizational processes and procedures.